face detection using Open CV and Haarcascade. So the first thing which we have to do is, of course, install OpenCV. Now I already have installed OpenCV, but I'll still show the command. So as you can see, I write pip install OpenCV and it says requirement already satisfied because I have already installed it. The other thing which we will use for the face recognition is Haarcascades, and that for that you don't have to actually install any new libraries. It actually comes with OpenCV, but you of course need the XML file, which is kind of the weight for Haarcascade. For that, you can actually go to OpenCV repository, open source repository, and you can actually find the whole Haarcascade list. Actually, they have a bunch of Haarcascades. So if I go just one route back, you can see actually they have Haarcascade for eyes, for face, for full body, etc. But we are trying to detect only the face, so we'll kind of use just the default one. So I have already kept the file for the Haarcascade downloaded, and I have also created a basic file which is nothing but it uses OpenCV to start your video stream. Just to explain, what we are doing is we are importing the OpenCV, then we are trying to capture one of the video source. So let's say in your laptop or in your machine you have multiple video sources. That can be, one can be your primary webcam or an external webcam. So every video input is provided with an index, but my machine already has one video source, which is my laptop webcam. So I'm just using the index as 0. And then what we are doing is we are creating an infinite loop where what we are doing is we are reading one frame. So actually from video source we get video as frames. So we read each frame, and right now it's a simple script, so it shows that frame back, and we are waiting for 30 milliseconds or something. Like we are trying to do like something like 30 fps, 60 fps. Like you cannot show a lot of frames at one go, so it kind of delays it. And if you stop the script, it just stops the whole window. And the end, if the script is stopped, we are just releasing the webcam source, and we are just destroying all the windows. So let's see this script in action. So if I just write python 3 main.py, theoretically what it should do is it should open. Okay, so as you can see, it has opened a webcam, and my video stream is just relaying here. So but this is what not we need. What we need is to actually detect faces inside that. So let's start. So the first thing which we need is actually a Haarcascade classifier. So let's create face classifier, and let's name it like this, and we'll just say cv2.cascade classifier. So like I said, the cascade classifier actually comes along with OpenCV. So now we'll actually load the model weights which we set. So we'll just say load, and we'll say cv2.samples.find file, and we'll just get the path for the file. So this is the file, we just give the path here. So with this, actually we have kind of loaded the classifier. But now the next thing is using this classifier to actually detect the images. So for that, let's go step by step. So here what we'll do is, let me just add some space. So whatever we have to do is between this and this. So this is where we read the frame, this is where we show the frame. So whatever detection and everything which we have to do has to come between these two. Now let me explain, before actually coding, let me explain what we are trying to do. We'll take the frame from actually the webcam, and we'll do some operations that can be converting that RGB into gray. And once that is done, we'll pass it to the classifier. Classifier will tell us, okay, the face is starting from this XY coordinate and the width and height is this. And accordingly what we'll do, before sending frame to the window, we'll actually create a box, rectangle box around the face, and then we'll send that upgraded image or that customized image to the webcam, to the window, and the window will actually show you the frame with the box on it. So that means with all the frames coming in, let's say for our whole video, each frame will actually be going through this whole process. The box will be created and then it will be shown. So the implementation will be on images, not on a video, but those images in sequence makes it a video. Okay, so let's start. So we are right now here. Now I have some series of operations which we'll do. So let's say we make it first is to gray. So what we'll do is we'll actually try to convert the frame into gray. So cv2.convert color, and now what we have to do is source is our frame. Now what next is there? Code. Okay, so code is in what code you want to actually convert it to. So what I want to do is cv2.bg color, then bgr, bgr to gray. So we want to actually convert it to gray, and that's all. Now so if I just do one thing, if I right now Okay, so let's start right now. I have not done anything, I've just added one line. So now right now start, it will actually show me a colored video like you can see. But we actually added a gray window, right? So that is because we actually are passing directly the frame. So now what I'll do, I'll actually pass frame gray. So now if I actually run the video stream again, you can see that my same video is actually converted to gray. So that's how we are actually, we are changing or modifying the frame before sending it to through the window. Okay, let's do some more changes. So this is one thing. Now what we'll do, we'll take this frame and we'll pass it to the classifier. So let's try, we actually can also do a lot of other things before passing it to the classifier, but first right now let's just try passing it to the classifier. So what we'll do is we'll say, face classifier dot detect multi scale, and we'll just pass the frame gray here. And right now I'm not doing anything. I'll just pass it to faces, so it will return some faces, imagining, and we'll just print this faces. So I'm not right now, I'm even not doing anything else. I'm just reading it, but as you can see on the terminal, it is actually printing the values. And if I may move my face out, or let's say I cover the webcam like this, it stopped detecting the values. But if I bring it back, it again detects my face. So these coordinates are actually x, y, width and height for my face. Let's see how to convert them into actual meaningful thing. So what we have to do is, so as you can see, it's actually a list of lists. So if there are multiple faces, it will actually give you 2 coordinates. But here in our case we are just 1. But still, what I'll do is I'll write for face in faces. So for each faces we will actually iterate. And what we'll do is we'll actually create a rectangle on the frame. So how do we do that? So I'll just call it new frame equal to frame, or I should say I think cv2 dot rectangle. Yeah, okay. Now again you have to give the image. So the initial image which we have is frame gray. So on that we actually want to create the thing. Now as you can see, it says 0.1, 0.2. So now a rectangle has actually 4 points. So why does it say only 0.1 and 0.2? So for creating a rectangle, what you need essentially is just the diagonal 2 points, and you can actually create the whole rectangle with it. So what we'll do is we'll actually pass 2 points here. So the first is x comma y. Now there is no x comma y right now, but I've written it. We'll find out x comma y. Okay, first let's find out that only. So actually if you see what do we have in the frames is list of list. So when we iterate like for face and faces, the face actually contain a list. So if I do like this, width comma height, and I say face, so now what will happen is x, y, w, h. X will have the x coordinate, y will have the y coordinate, w will have the width and height. So I'll say x, y, which is at this point, and then I have to actually move to the next point, which is the diagonal one. So I'll just say x plus y, so that I move horizontally, and then I'll say, sorry, not x plus y, I'll just write x plus w, so I move horizontally. Then I write y plus h, so that I move vertically down. And with this actually we have kind of, told the OpenCV to create a rectangle, but now we have to actually tell the color. So let's say the color, I say color equal to, for now, 255, 0, and thickness, as you can see, thickness equal to 2. Now, okay, this we have done. And now what we'll do is, instead of passing frame gray, we'll pass new frame here. Let's see what it does. So as you can see, it is actually creating the image, the rectangle around my face. But the problem is, it's a black and white image. We actually passed a colored image. So what we'll do is, now instead of actually writing it on the gray frame, we actually pass it on the frame, direct frame. And let me also remove this because it's actually just creating noise. So now if I run the same script, now because we have actually drawn it on a colored photo, it is actually creating the colored window out of it. So with this, you can see my face is being detected, and it is also detecting here and there sometimes that it is a face, but mostly dominantly it is detecting my face. And if I cover my face like this, it stopped detecting my face, but as soon as I bring it out, it started detecting my face. So yeah, so we have kind of actually detected our face using the OpenCV. Now we can actually do other operations on it, but it's not that much required. So yeah, this is a normal script to actually detect faces. And with this, we can, after detecting the face, we can crop this frame, send it to for some next post processing, etc. The things are actually a lot which you can do after that, but this is a basic code of how you can detect a face from an image using OpenCV under 19 to 20 lines of code.